Today we will attempt in a group to build a hopefully better NLP model than what's currently available out of the box if you just prompt a large language model. And we've already run some experiments, it's looking pretty good. So we'll all be working together on this. And to give you a little intro, who we are, what we're doing, we're probably most known for Spacey, which is an open source library for natural language processing in Python. It's been very popular, and it really focuses on applied real-world use cases, building pipelines, combining different techniques from the latest machine learning models to business logic, and it was really designed from the ground up to be used in real projects and in production, and it's also very fast. And we also publish Prodigy, which is an annotation tool that integrates with Spacey and helps you create training data, both in efficient ways in the UI and also in smart ways by automating things. And Prodigy is very widely used by lots of different companies and users in all kinds of industries, and it covers a wide range of tasks. And we'll also be using Prodigy and our latest upcoming product, Prodigy Teams, which is kind of brings the whole thing into the cloud and is a collaborative data development platform to create some data for the model that we're going to train today to see how good we can get and how we can surpass what's currently available in the world of large language models. And so one really important distinction I want to start with for this workshop is the distinction between generative and predictive models and capabilities. I feel like if you scroll through your LinkedIn feed or follow the news on everything happening in the space, this is often kind of talked about as one thing and sort of presented as the same thing when actually these capabilities are quite different. So usually when people talk about stuff like ChatGPT, these models are really good at these generative tasks. So we have stuff like summarization, reasoning, problem solving, paraphrasing, style transfer, question answering. And these are all tasks where text comes in and a text or something else comes out and is generated. But then there's this whole other area of predictive tasks where the output is really more machine readable and the model is more of a part of a larger system. So that's stuff like information extraction, text classification, entity recognition, relation extraction, co-reference resolution, semantic parsing, discourse structure, grammar. So all of these things that maybe people call classic NLP tasks, but they're still extremely important because there are many use cases where you want to populate a database, you want to create structured data. And while a lot of the large models that are coming out can really help with that, they're actually surprisingly, sometimes surprisingly bad at these things, which you wouldn't believe, if you're just scrolling through your LinkedIn feed and get the message of like, oh, NLP is practically solved. But if your goal is to create structured information out at the end of it with a generative model, there's a lot of room for improvement. So that's also what we're looking at to see, hey, how can we get past that? And how can we maybe use what's clearly there and all the great capabilities that we also use in our everyday life, like using ChatGPT to help with writing code and answering questions around that. There's like a lot of, clearly there's like so much in there, but how can we use that and kind of take it to the next level? That's really what we want to focus on in this workshop. And to give you some examples, these are some experiments we ran before, where we basically looked at how does a model trained on data, like for a specific task, compare to a zero or few shot results you get out of the box with different large language models. And basically here, the dashed lines, those are the baseline with no training examples. And then you see the results of models trained on different portions of the data. So 1%, 5%, 10%, and so on. And what we can see here is that for especially the sentiment data set, news data set, we get like pretty good zero-shot results out of the box, and that's something to work with. But for harder use cases, even with like very small amounts of data, like 1%, 5%, we can definitely beat those scores and build a model that's even better for that one specific task. And especially once the task gets a bit harder, like banking data with 77 categories, which is domain specific, a lot of labels, and here, even with 5% of the data, we get like, a huge improvement. And if we train from the whole data set, that's like a very, very, significant difference. And recently we also ran some experiments for named entity recognition, so extracting named concepts from text, which was very difficult because a lot of these models keep timing out. It's very hard actually to run these structured experiments, and especially the more you include in the prompt, the more hopeless it gets. But basically what we've seen here is that even with 20 training examples, on this data set, we can beat the Claude 2 model. So all of this looked very promising to us. We were like, okay, how can we turn this into a workflow that's actually usable by people, and how can we extract the information that's there and then build better models that are faster, really specializing on this one particular task. And how do we find these inflection points, basically, where we can see, okay, that's how much data we need to train a model that outperforms the baseline, or the best possible baseline. So that's also what we try and look at today. How can we get there? Can we get there as a group? And also, what workflows are there that let you use these workflows in your day-to-day NLP life? And so what we're going to try and do today is this. We'll use data annotated by a large language model, and using a prompt that we've tuned and identified as at least the best possible one. We're going to use the predictions to help us create data that's correct all the mistakes, and then use that data to train a supervised bird-sized model that's smaller, more efficient, that you can run on your modern laptop these days almost, or on a single machine. And then during inference, we'll have this spacey model that hopefully should perform as good or maybe even better. We'll create our model. So we're going to use, instead of using the large language model or an API at runtime, we're going to use it at development time to get the best possible information out of it, and then turn that into like a distilled down version that's better and more efficient. So that's what we're going to attempt interactively today. Also, if you haven't signed up yet, there's this bit.ly URL on the whiteboard here. Just put in your details, and then we'll invite you to the platform we're going to use to collaborate on the data for our model. And now I hand over to Ryan.
Awesome. Well, good morning, everyone. We're very excited. As always, workshops, especially demoing new software, is always challenging, but so far. Before we get into the workshop, just a little bit about myself. So my name is Ryan Wesslen. I'm a machine learning engineer at Explosion, and also the Prodigy customer lead. So I've been working with Explosion for about a year and a half now. And I'm not just work for Explosion, but I've been using Spacey and especially Prodigy in previous roles. So I previously managed an NLP team at Bank of America. So Prodigy itself, I think, as Ines had kind of said, is a Python library for fast, efficient data annotation. So today with the workshop, what we actually want to do now is start to use our a software as a service platform called Prodigy Teams. Just as one more hash, because I know that there's still a few more people, but getting into what the actual task that we're going to be doing is, as Ines was saying, named entity recognition. But we want to actually now start to take it one step further by allowing the large language model to pre-annotate the NER model. So I'm just curious here, who here has ever labeled any data for an NLP model? Got 1, 2, 3, 4, 5, 6, 7. I like the couple of hands that's like, well, I kind of did in Excel. Does that count? Labeling data is a challenging problem, especially for applied NLP. It's very easy to find, wonderful notebooks with data sets that have already been labeled, but for a lot of practitioners, actually applying it to specific problems requires you sometimes of rolling up your sleeves and labeling data. So, especially for those of you guys that are familiar with labeling data, you've realized that, it's a challenge in a lot of ways. Determining for, let's say, a task like name entity recognition, defining what is an organization. It might seem intuitive to begin with, but then when you actually look through, trying to define what that entity type is can be a little challenging. So as the first example that we want to kind of walk in pretty slowly before we have our major task, which we'll let you guys label for 15 minutes, we want to first do what we're calling a QA or kind of pilot annotation. So this is where what we'll be doing is looking at Reddit data. So we'll be specifically looking at the subreddit of cooking. And we wanted to try to find a task that was fairly intuitive because, again, sometimes some NLP tasks can be very specific. Maybe you're looking at medical terminology, so you need an incredible background in that specific field. And this was also something, too, as Ines had kind of showed with some of our initial results, at looking at large language models kind of pre-annotation. So this is, again, 0 shot where you might only give them a prompt, or a few shot where you give them a prompt and a few examples. It really varies as far as how well they can actually perform depending on the task itself. So we decided Reddit cooking data, one, because it was something fairly easy to define a prompt, and we could prompt engineer that, and we have a few examples of the prompts that we use. But more specifically, we wanted something kind of clear-cut in the definition for you guys as well, too. So with the subreddit for cooking, what we're going to be looking for are entity types that are either a dish, an ingredient, or equipment. And there's a lot of ways, maybe thinking about the practical purposes is maybe I want to try to look at Reddit data and I'm in the business of selling cooking equipment. And I want to now start to target what are the big trends? Is it certain Mexican dishes that are becoming more popular? And what are the equipment that people are using? So this is where, again, this idea of name entity recognition, this information extraction task could be potentially very valuable if we were able to define and build our own model. And so we have these definitions, and as you guys start to go through, you'll find, well, these definitions make sense. Everyone's kind of maybe had their own recipe and try to create their own dish. And thinking about like ingredients, well, when you think about that, it's really as what are the inputs to a dish itself. You can think of the dish as, say, the output, the final thing that you're actually going to be consuming. Whereas then the equipment might be the means that you get to for that actual dish itself. So these are, again, some of the things to think about when we go through our first pilot kind of Q&A, where we'll talk through the first 5 examples. But as I do this, I do suspect that we might have, and we can actually switch over. This is actually, so just one heads up is that we've sent out invites. So if you see your email address here, you actually need to go to your email and just acknowledge that you've been invited to the system. Because until you do that, I can't send you the link for the annotation itself. So there's a few people here. And again, I would actually say for this first one, if you don't want to even actually annotate, that's completely fine as well, because we'll talk through these first 5 examples. And then I also suspect we've gotten a few, 36, and I was at 30, so 1, 2, 3. Yeah, so what it is that, so like for example, I'm adding these 6 people. So if you see your email here, you just need to go to that email address and then acknowledge that you've been sent this invite to go into the system. Because once you're in the system, then I'll actually go to our task and assign you to do the annotations for those. So again, let me pause to make certain everyone, because there's about like 20 people that they're all ready to go. I can start sending out the annotations now, but I don't want to leave anyone behind. But I know it's lots of things. It's first thing in the morning too. It's raining, Let me see if that's that number going down, so we still have 12 more people. So again, just in the interest of time, if you are, again, you would have to just go to your email and acknowledge. But while we're looking at this too, just to give you guys a sneak preview of Prodigy Teams, our latest product, this is the user interface where for a developer or admin would be able to manage, start, create, stop, and also assign tasks for annotation. So in this example, we've actually already created 2 separate tasks, our NER tasks. And what we're first going to be doing is this QA pilot, or what I'm now going to do is everyone, so we have 28 people, I'm now going to add you as annotators. And so for that, now you should have received an email that says, Ryan Wesslen has invited you to do a labeling task, and a big old button. Hopefully everything will, we already are starting to get, so if you were to get that email, it would then hopefully lead you to, dun 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 dun, boom. There's some people able to, yeah.
Maybe next show of hands, who can see the annotation UI?
Okay.
Yeah.
Things are working. Now, one fun thing we have with this, and I think a few of you guys maybe have used Prodigy before, maybe other annotation tools, we actually added something, this callback to these 5 examples that we want to label first. Because what we want this as is a Q&A. That is, if you don't get the correct annotation, so we as a team actually went through these 5 documents and annotated them, you'll actually get a pop-up box that says, no, your annotation isn't correct.
I'll just do it here, so let's say.
Yeah, so, you can do soup. Let's pause, or actually, no, curry is in that context a dish.
Yeah, so I did it wrong now, and now.
Yeah, so, well, no, so there's one, actually, if you just switch curry to a dish. So, and then pause 1 second. Yeah, so one thing that's already challenging, what's the difference between an ingredient and a dish? Sometimes, again, maybe a stew might be thought of as an ingredient in some ways, but then sometimes it also might be kind of that actual last output, that dish that you're serving. So one of the first things as you go through this task is really thinking about the context itself. How is it actually being used in that sentence as a dish versus an ingredient? Now, looking at this, is this a correct annotation, or is there anything that we could improve upon this? Cauliflower. What is it, just cauliflower, or cauliflower leaves? So one thing to think about this, in information extraction, we are taking unstructured text, and we want to try to carve out what are the specific things we want to extract out. And if you think about this, if we were to say just cauliflower, that might mean something completely different than cauliflower leaves. So we need to be extremely mindful of the actual bounds of the entity types. And for those of you guys that are deeply aware of kind of NLP tasks, especially name entity recognition, the boundaries is incredibly important to be specific on. Now, whereas for some, especially any Spacey users who've maybe used our span cat component, that's one that has a little bit more flexibility in allowing you overlapping entity bounds. But in this example, we need to be very thoughtful about the boundaries themselves, because that's the way in which, for the model to be trained, it's really looking at very defined boundaries. So for this, you can click this. Now this second one, you already jumped to it.
Oh, sorry.
Yeah, same.
Yeah.
So what's the issue with this? So our large language model in few shots said, this is an equipment. Yeah, the my is in there. So in this, we're actually just really looking at, so we would then go to equipment, Pro 50, and that's what we're looking for. So,
See the boundary annotation?
Yeah. So to Ines's point too, and this is actually something that, especially if you haven't done a lot of data annotation before, one thing that Prodigy does is using the tokenizer allows you to do these snap boundaries. One thing just in my experience, and I remember this 5-6 years ago before doing NLP, I thought tokenizers was a very trivial thing, but when you're actually annotating, especially spans of text, what tokenizer you use at the time of annotation is extremely important because you need to have a consistent tokenizer that you're actually using during training as well too. So if you don't have a tokenizer that allows you to snap, there's always the possibility of a human error that I accidentally go a little bit too far or too back or from a specific actual text itself. So that's again just some of the things that's built into Prodigy. So here's another example. So we have the large language model had predicted these ingredients. Is this correct? Anyone want to? Good. Yeah?
I just say garlic or minced garlic.
Oh, you would say garlic versus, you don't think minced garlic is?
That's part of the process.
That's part of the process. Oh, that's an interesting thing. So we actually talked about this and we were actually thinking that like, when you actually are putting in the ingredients, we thought minced garlic is what you need because if you were to just have for that just regular garlic, so that's actually, but this is where it's a great point on that like thinking through, we actually were thinking that it would be minced garlic. But I think you bring up a fair point, yeah. Oh, the cups, the measurements? Yeah, this is really the one why we wanted to kind of show this example. We have decided, and this goes back to our definitions, that measurements are not a part of the entity. Now again, some would argue that to get the recipe, you might actually want that. And this is where what you might want to do on a second round is now having a fourth entity type called the measurement. But what we decided as annotation guidelines, and this is where it's just so critical before you start annotating, you have a clear knowledge and thinking about what are you trying to annotate. And there's not a perfect definition. So for example, if we were to be very clear that like we think garlic should only be there, not minced on that, we just need to define what that is. But in this case, we made the decision, and for your labeling task, that measurements won't be a part of this entity type.
It's an interesting one because like, yeah, in English you have like the cup that's like, in this case, a measure, like a unit, but also an actual cup. So you can't like, there might be cases where like, I don't know, stir an egg in a cup where the cup would be an equipment and then the model could get confused because in other languages your measurements are a bit more.
Yeah, and one of the nice things, and especially when we get in about 5 minutes, once you guys start labeling for 15 minutes, you will find so many counterexamples of things you never even thought was there.
Yeah.
And this is the beauty, and this is also why I also be clear, or think about this from my experience. One of the reasons why like I loved Prodigy as an NLP practitioner, because there's a lot of times that a data scientist think annotation isn't my role. That's someone else's, that's the annotators, just give me the data, I just have to hyper tune my parameters and that's it and call it a day. And instead with Prodigy or a lot of other annotation tools, for data scientists to get their hands dirty, especially early on in projects and trying to define, well, what are these entity types and being very clear about it is one of the leading ways in which projects can be successful as opposed to when they fail, because you're not even defining what are you trying to label. So in this is actually one that we as a group, now again, we could debate and maybe there's whole other things, but we actually decided that one was correct. 2 other ones. So in this one, is this correct? Why not? It's a dish. How did you infer that?
There's no other food.
Oh, there's no other food? Yeah, and it's talking about the sides that are there.
Yeah.
But this is another one and this is where, my background's more in psychology, like human language, understanding how quickly someone can read that and immediately infer that versus, and although not to get too hard on large language models, when you guys start annotating, you will be very impressed with sometimes their ability, but there's other times that they still struggle on this short context. And so this is, again, the whole idea is we build from the large language models to kind of get us a good first start, because it's much easier to correct than if there was nothing on there. But it's as well something that, someone can try to figure out. So this is the last one before we jump in. What's the thoughts on this? TV show, that's actually a TV show. So it's again one of these that, thinking about the context, But one other reason that we want to show you this example, and some of this is also the design of Prodigy, is so Prodigy is designed for one document at a time, allowing annotators to make quick, efficient decisions. We sometimes have Prodigy users that want to put like all types of data, just like 5 pages of documents, and instead it's not really built for that. It's built for a very quick decision. And one thing that I just want to note on this is that Prodigy has this accept, reject, and ignore buttons. So in this context, even though I don't have any entity types, I would still be accepting this because it's an example where there aren't any that the model needs to learn from. So when you guys go through your actual task itself, if you go and come to any that there aren't entities in there, that's completely fine. And that's still something that you would click this button, or you can actually even use the keyboard A for a fast shortcut on this. The reject button that's there, that's usually only times where you want to throw out an example. Maybe you have a poor tokenization or something like that. For probably the vast majority, you guys during your task will just highlight the spans and then move on to the next one. And then the last, just for context too, before we jump in, that third button, the skip, that's one that just again, it's almost like you'll get back to later. I also want to say with the task that you guys are going through with Reddit data, we chose specifically the cooking subreddit, hoping that there might not be explicit language, but social media finds a way. So we, again, tried to curate and try to remove, but there are some explicit language. So when you are labeling, if you're one of the lucky ones that get one of those documents, you're more than welcome to just skip it and not have to read it.
So like skip in general, I think is a good strategy. Like don't waste like minutes on a single example. Like I also did a bunch of annotation before the workshop, and there is some stuff where you like, yes, you can sit down and debate like on a philosophical level, what's a dish, and Google some stuff, but like it's kind of not worth it. The value of the individual example isn't that high. Like it's much better to stay in that groove and move on rather than really getting too hung up on one example that might not make a difference. And yeah, also once we're getting to it and like you get to annotate, definitely remember to, like if you see some cool examples, some interesting ones, some funny ones, there's definitely like so much in there. Take a screenshot. We can also discuss some of those later, and they also make really good content for social media. Some of them are really really good. And if you definitely don't forget to take screenshots of what you come across.
Oh yeah, and so before we actually get into the task, one last thing that it's just good to have a good mental model about an annotation process is that we kind of have this feedback loop where at this first step, and then you can think of this as even this QA pilot, we first want to annotate it. The second and very, very critical is this evaluate. Now again, if we wanted to go through this as say a lot of companies or a lot of initial projects start, this could be several hours to several days. This is why we wanted to go through these 5 examples to talk through as a group, talk through, whether we agree or disagree with what our definitions are. Do we know what we're actually labeling? Do we find that we might need more data or other circumstances? Again, given this workshop, we've really kind of oversimplified this. But then the third part is then now that we've had any of those discussions, usually if you were again to put this as a model or a project moving forward, you then might want to update your annotation guidelines. So maybe those 5 examples, maybe it's a document that you put those 5 examples along with the definitions so any new annotators can kind of learn from those examples. We do have, and we don't have a link to this, but about a year ago, I wrote a wonderful blog on The Guardian, the newspaper that used our tool Prodigy, and they had a wonderful annotation guidelines on finding quote extraction. And the reason we wrote that blog is that I think for a lot of NLP practitioners, they might not have even seen what good annotation guidelines look like. And it's again for some that being able to look through that kind of set of definitions and iterating on that was something that the Guardian team had actually worked on pretty effectively for this. So this is again, this whole idea that we can't fully go through this because this might be, several hours, if not several days. But it's again what we want to try to zoom into in this workshop for now.
Yeah. Well, yeah, we can go through this a bit quickly. I will also share the slides after, but basically what we've done is we've configured Spacey via its Spacey LLM package to use an LLM GPT 3.5 in this case to pre-label examples. On the right side, you see the prompt template. We also use different prompt templates for comparison. And yeah, so that's kind of where we're at out of the box. So we started, labeled some evaluation examples because we need to be able to compare what we're doing and how different models are performing. And here's this is the baseline. That's what we are trying to work against. So as you can see, we've tried a zero-shot approach, so just prompt, take whatever we get back. We've tried the chain of thought prompting, which we've also implemented in Spacey, and we've tried a few-shot approach. So these are the results, and what we're trying to find out is where can we get compared to this with a task-specific model that we trained that really only does this one task. Yeah, but actually, I think we're actually getting closer to like a sizable data set that's also similar to the sets we've done experiments with. Also, as you can see, like this wasn't like a very focused annotation session. People were chatting. It was more fun, but still, we created quite a lot of data. So you can easily imagine that if you actually sat down with a team of people and did this focused as part of a job, you could very, very quickly create quite a lot of data that way and have enough to train a model. So yeah, Ryan, you just want to quickly show like how what the next steps?
Yeah. So just to, again, go back to the Prodigy Teams user interface. So this is, again, the thought process of this product is you would have an administrator or developer who's the one that's administering this task. And so all of you guys were annotators, which was a separate role. That is, you only get the link to your specific annotations and the tasks that are there. But this gives a little bit of a high-level summary about, what's currently going on. And you see this actually refreshing with some of these examples. Let's see if I can find my mouse. Oh, there it is. And so again, we can actually look through some of these. What's really nice as well too is you can actually look at the actual JSON structure for this. There's lots of nitty-gritty details that actually is being done underneath the hood with the tokenization that's there. But some of the other key things to just look at is, look at what we've accomplished in 30 minutes. We have 734 annotations, which is a lot. About 7 hours worth of work you guys have done. You guys need to take a break. You guys have been doing amazing. Look at this, already in the morning and 7 hours worth of annotations.
Also, if anybody has unsaved.
Oh, yeah.
Before you close your browser, make sure to hit save or Command S if you're easy. So we the last little bit.
Yeah, and as you guys are kind of finishing up, and so if I were to, just so you see, so there's this little button, because the way in which Prodigy sends out annotations is in batches. And so until you actually get through that, usually that 10 batch, it's actually saved locally in your browser, but it's not until that point that either you get through those 10 that then it retrieves 10 more of those, or you click that save button. So it's only the last 10 or so that are there. Oh, actually, no, I take that back. You guys, now that you saved, it's actually about 1,200 annotations. So thank you for that save. 10 hours worth of work. Amazing job, you guys. So again, this provides some of the information for, let's say, the administrator or the developer to kind of look through. We can also actually see the individual sessions. So, I did my contribution of one annotation, worked really hard. But thank you to some of you guys, 26, 30, 32, 58, well done. There's also a lot of other features that, and this is again just a preview, where you can actually look at the logs. This is extremely helpful to debug and any issues that are come about. But what we also have, so in Prodigy Teams, there's kind of two things that you can do. The first is a task itself. So this is like where we use the NER, what we call a recipe, which just think about that as kind of the structure of what the task is. So maybe defining what the label is, the data set that's there. This is where, and just as kind of a quick preview, if we wanted to right now, hey, we've done 10 hours worth of work, let's do some co-reference resolution while we're at it. We won't, of course. But this is the normal kind of structure as what the product would then allow you, maybe image annotation. But the second thing we want to show you too is the actions part of Prodigy Teams, which is really nice because what you might also have is some sort of computation that you want to do on your data set. So usually the most obvious one is, say, training. So you could actually go through, we decided to just avoid the complication of that, but in theory, we have it kind of preset with a Spacey pipeline. But again, there's nothing holding you back from potentially running a PyTorch pipeline or any other framework. But in advance of this, we actually, and my colleague Kabir created this wonderful recipe that just does some nice overall statistics on our big data set that we had. And as I'm kind of rerunning this, so this is some very basic information of the fruits of our labor. So we went through 1,200 examples. 333 were examples without entities. So thank you guys for doing that. That was back to the point that you still accepted when there was a document that didn't have any entities on there. So maybe about a fourth. In total, 3,700 actual spans or entities that you guys labeled. We can actually look at the size of this. So a vast majority were ingredients. Dishes and equipment, which this is pretty similar to what we've seen before when our team did some internal testing for this. What's also really nice too that we kind of had, and again, the whole idea of this is that with this action, you can write a Python script to do whatever you want. In this example, what we just wanted to do is to show the top 10 most covered entities. So butter as an ingredient, very popular, makes sense. Pan and equipment. We also have other oven for equipment, but again, this is good. We have some good quality things. We're not assigning olive oil as an equipment. So this is a good kind of test for this. What's also kind of interesting too is this 10 least covered entities where we might try to find some inconsistencies sometimes. Now we do have some case sensitivity, so also Buko in both contexts were assigned a dish. At some point, we assigned hypertension an ingredient, which is, so the one key thing I would say on this, so two things is, remember that when we have this data pre-annotated from large language models, I hope one takeaway from this is how powerful large language models can be. There were some contexts, like I remember annotating where there might be a full paragraph of all these ingredients and large language models with FewShot can detect a ton of them immediately. Meaning you as an annotator don't have to exhaust your very precious cognitive load annotating every single one. But every once in a while, the model is not perfect. This is again, the value of you as a person. And so my suspicion, and I could be completely wrong, was this was one where the large language model had assigned hypertension and someone just had kind of moved forward with it, or alternatively was confused on this. But again, one annotation like this in the grand scheme of things is not the end of the world, and it's actually something we would assume in a lot of annotation workflows as well. So going through, we actually had, and this was a really kind of other cool analysis that Kabir had put into this, is also comparing some of the entities where we've assigned them different labels at different times. So we can actually see this, and this actually makes a lot of sense as we were talking about it, that there are some entities that it really, again, depends on the context. Like that example that we showed with turkey, if I say I'm gonna put turkey into my sandwich, that turkey is actually an ingredient to my sandwich, which is my dish. But if I say I can't wait for Thanksgiving and our amazing turkey dinner, in that context is more as the turkey is that actual dish itself. So this was, again, a nice little comparison where we were just trying to, again, look at some very basic statistics and comparison of, okay, how did some of these different entity types compare when they were used as two different entities? I think there's a couple other, wow, we have a lot. Oh, and there was actually a few of these too where we might find, issue. We would expect this a lot, and as we saw with dish versus ingredient, but we did have a few, or some examples that, we might have found the contrary. And so again, we're all human beings. We make mistakes. We can't expect our data to be 100% perfect. And usually in this process, what we would actually want to do is multiple rounds of the data. And we'll get into this a little bit, but you might want to have certain people annotate the same examples and have some adjudicator or inter-annotator agreements as well too, where you go through multiple stages to try to avoid some of these issues in the data itself. But again, this is where we wanted to show you guys that not just the platform has some of the very basic statistics, how many annotations, but there's also creative ways of using these actions to try to look at specific annotation stats to kind of help someone that's administering this task as they have many annotators real time.
Of course, you've been wondering, how did we do with our annotations? Well, of course, we're not going to live train a bird-sized model because that's going to take too long, and we also can't rely on the internet connection. But what we did do is we actually already prepared, as they do in these cooking shows where they kind of, bring out the slow-cooked beef they already prepared. So we did run our own experiments. We annotated, how many examples did we have in total?
It was actually very similar, about 1,000.
Yeah, it was actually, and I think it was actually fewer than we all did as the group. So with more examples, we can expect the accuracy to even go up a bit. So that's what we did. And so as you can see here, we actually managed to train a model on this data that is kind of on par with the few-shot approach. It does run a lot faster at 2,000 words a second. It's very small. You can have it running yourself. And we also did do a bit of hyperparameter tuning. I don't know, Matt, if you want to comment on some of that, but basically to make sure that's something we don't have in a product yet, but that we were able to do locally to make sure we get the best possible results out of the data. So even though you might be looking at this and you're like, oh, it's kind of the same. What would I want to do all of that? It's still, this model is how large? 1 gigabyte, maybe less, right? No.
Yeah, something like that.
Yeah, it's like less than a gigabyte. You have it as a little package. You can run it yourself. You can run it on your laptop. It's entirely private. It really only does the one thing that we wanted to do. You can update it with more examples. You can add more, some rules to it. You can add other components to it. And 2,000 words per second. That's really, really good and really fast. And it's not even the fastest you can get there. Also, if you train like a CNN model, depending on what you're doing, that will run at how fast? 20? 10?
Yeah, about
10 to 20K words a second. So there are kind of trade-offs to be made here. But yeah, that's our results. And I would assume that using what we've created today, we would be able to train a very similar model. We're going to share, after this, we're going to share the slides. We're also going to share the configs, so you can repeat something similar at home and train your own models. Some quick takeaways from what we did today. As we've seen, generative models, they can really complement predictive methodologies and predictive models. It's not a direct replacement. Even though there might be people who believe that, or there might be if you follow a lot of the reporting, it's pretty one-sided. But there's always a place for structured data, and you can use these models and what's in there to better create that for you. But letting the model itself create that structured data might not always be the best approach. Like, you can usually do better than that and distill it down and build something more specific. Because one great thing about structured data is that you know a lot more about it. You know its structure, and you can use that to your advantage when building better models. And this is the wrong one. If you can do that, you'll be able to create much better, more accurate, much faster, smaller, and also fully private models. You don't have to send anything through an API. The model can really run locally on your servers, which is very important for a lot of use cases, and also quite cool. Like, why not if you can do it? Can always take it to the next level. And finally, tooling, as we've seen, is really important. The human has a lot of disadvantages, like paying attention to stuff, performing a lot of steps in a row. It's kind of, in some ways it's great hardware, in some other ways it's very inefficient. And if we can use tooling to get the most out of the human where we really need it. And all of that together, hopefully we see as like, very promising path towards using everything that's new in NLP to really make a difference. Thanks.